Welcome to Global Technology, Tech 5173. This is a great day when students bring their labor during the semester, each group working on a topic of their own choosing, with a team of their own choosing. And they go and study to know everything about this thing. Of course, nobody can know everything about everything, but they will know at least better than us. Now, I want you to be open-minded and just absorb what they say and enjoy. Okay? Now, with this, I would start with the screen here, nothing on it for now, and TIYDS stands for? Very good. Let us look and the screen. Another, wait, please hit another one. This is your day. Shine. One more. One. Very good. Would you clap your hands for the group who is going to start in a minute? So, please.
Good evening, everyone. I'm Darnell Henderson. This is Chuck. This is Scott, and this is Manny. And today we'll be talking about 3D bioprinting. So to start, I just want to let you know about how 3D printer works. All right, 3D printers work like inkjet printers. Pretty much, you design something on a computer or some type of software, get a model or whatever you want, then you send it to a 3D printer just like you would do when you're doing your weekly reports or you're writing research papers, and then the printer prints off what you want to print. All right, what we have here is just a brief description, kind of a graphical representation of how 3D printing actually works. The first part, you have the laser source. And, it sends a beam to kind of, form the material into what it's actually going to be. So it starts off as a kind of ink, and then it solidifies it. The next step is the elevator. And the elevator, pretty much, like the name in itself explains it. What you have is different levels to what you're trying to print. So each time you want to print a level, the elevator goes up. And when it's finished, it goes up to the next level. The third is the vat, and that contains the actual material. So it could be, like mentioned later on, gold, silver, titanium, plastic, anything of that nature. Then, yeah, that's pretty much how it works. All right, these are just a few things that I found as far as history. The first one, which is the white ball with the dropper with the red stuff in there, is it was the first lab-grown urinary bladder, and it was created in 1999. The second one, which is the top picture with the black background, is a kidney. That was created in 2002, and that kidney was able to filter blood and produce urine in an animal. The next one is a prosthetic leg. And the whole leg, from the toes, the foot, the ankle, the knee, all of that was printed all from a 3D printer. There was no assembly required, and it was actually used on an actual person. The next one is a prosthetic jaw. The significance of this was it was actually implemented into an 83-year-old lady, and it solved a chronic bone disease. So these are just a few things in the history of 3D bioprinting, and next I'll turn it over to Chuck.
Go ahead, Darnell. Just want to talk to a little bit about the medical application. So, Darnell, thanks for the history, a little bit on how 3D printing has developed up to this point. I'm going to kind of bring you up on the status of where we're at, just how that applies to bioengineering in particular. Because some of the 3D printing that's being done right now is with stuff that's just biocompatible. We're actually going to talk about biological printing here. So, like I said already, technology this is being developed for bioengineering and research of biological materials. This can be used for disease testing, organ tissue repair, and maybe eventually some organ transplants. The first printer that was made was the Tavideo bioprinter. It was made back in 2000, and it's actually an inkjet printer, and it was modified to to print complex patterns. They actually used an inkjet printer. And here is a picture of it. Looks a lot like your Canon printer there. So they just modified it in a lab, and it actually does print layer by layer tissues of whatever cell they need. The next generation is the Organovo Next Gen, MMX. So it actually produces a 3D layering of cells in a culture. And the first thing that they've tried to print with that is actually liver tissue, which they've accomplished now. They've been able to bioprint this tissue, and it responds the same way as your tissue does. It's actually human tissue. They use cells just right out of the same person's body. As I said already, for use as laboratory testing, tissue can be used successfully to see how the liver would respond to disease and to drugs. And it takes 30 minutes for this printer to actually print 24 samples. They actually just started doing it this year. It was supposed to be done by the end of this year, but it actually finished early. I'm just going to show a short clip here on how it works.
Organovo creates functional human tissues with its unique bioprinting technology. Starting with cells from any source, Organovo's bioprinter precisely places a specially formulated bioink, in this case, into a 96-well plate for drug discovery. The process results in...
I'll just go ahead and stop it there. But interesting to note is that there is a cell structure to it. So not only are there liver cells in there, but there's also a vascular system that it has to place in there too. Just to show a little bit how complex the liver is. And this is the actual liver tissue model here with the vascular network inside there. Now Harvard is also working on a bioprinting model. They've done it a little bit differently. The way it works is they actually print out the cell tissue, and then they print out a material inside there that melts and it becomes hollow. Then they inject the vascular cells to form the blood vessels later on. And they've actually done a 3D printed heart, but it wasn't an actual beating heart, but they did a high-resolution CT scan of a heart, and they fabricated it in a shop so that surgeons could practice on it with the actual defects of the heart and figure out how to proceed with it was actually a toddler that they performed the surgery on, and it was successful. I do have a little video on it, but because of time, I'm going to go past it. I'll just leave it up there for you guys to view. But just a printing of a blood vessel, there is an interesting one on there where it actually prints a blood vessel into what they call a hydrogel. It's a different way of actually 3D printing where it actually just prints layer on top of layer like that. It shows in the illustration there. And then just the complexity behind a blood vessel itself. There is muscle tissue with it, with the heart. They've actually been able to make some of the muscle tissue that could be used for repair in a heart. This is a picture of it here. And the actual, they're developing a separate 6-axis bioprinter right now that can actually print and assemble the heart at the same time because it's too complex to just print layer by layer. They actually have to print separate sections and then place those sections together, almost like building parts of a car or a plane. And they had to develop new software to do that. It was called computer-aided biology. And just putting a face on it, I like to do that. They were able to produce a windpipe for this young lady here, 2 years old. They did a print of her trachea, and they implanted stem cells in the fabric, and the trachea actually reformed where it should have been originally.
All right, I want to talk about the ethics in 3D printing, bioprinting. Of course, with any new technology, there's always going to be some type of ethical issues that come up with the technology. So just start off, there's always been an increasing wait list for organ transplant, and people not getting the transplants in time or just waiting in line for a long time. So the increased amount of 3D bioprinting could affect, allow for more organs to be made, but there's still going to be a lot of people on the list. So I'll skip to the next one. No, this is one slide. So in relation to that, illegal sale and buying of 3D printed organs, that's not a new thing with regular human organs. There's been a black market for human organs sale and buying. So that kind of could translate into the people on the wait list obtaining through pirating the designs of the organs. Like we've already seen legally people sharing designs of like toys or different little gadgets that people have printed with non-organs. But this is similar to pirating movies or music. So pirating designs for specific organs of different people's tissues kind of gets into the ethics of that. Yeah, so that's all I have to say about that.
Good evening, everybody. I've got future of 3D bioprinting. Till now, we have seen printing human body parts, and I don't think. I guess you guys haven't thought about printing meat and leather. This is actually an old idea of 1932, where Winston Churchill said that instead of growing the whole chicken to eat the thighs and breast of a chicken, there will be a technology which grows the parts individually, and that's a little funny picture. The thought behind this is right now we have 7 billion people in the world, and we are we use 60 billion land animals as our food, and in a span of 30 years we'll become 9 billion people, and we may need 100 billion land animals. So animals are like natural resources, so we need to save them, and this is a good idea to save the resources. This is the process of printing meat, where we take a perfect animal, we collect cells, and we multiply those cells into we take few cells and we grow billions of cells from that, and then we form layers using the bioprinter, and then we stack them in layers to form meat. In this process of growing meat, we take samples of fat, meat, and more cells, and then finally we can cook, eat. It is actually done in the past, like in 2006 or so. I don't have the picture. And this is the process of growing leather. Here, the same way we take a nice, a perfect animal. We take the skin cells, and then we grow the cells. Multiply the cells. We grow sheets of leather. We tan it. Tanning is other process which is minimized. If you got to tan the original skin, you got to remove all the hair and all the. It's a big process. Well, coming to this, the printed leather, you don't need to remove all the skin and all. You can grow the leather in required shapes, and finally you can finish dyeing, and you can design products. That's all. Thank you.
Very good. Thank you very much. If you can elaborate a little about the ethics. Somebody mentioned there are some issues ethical. What kind of ethical issues? It's not taking parts from somebody else and doing it, or stem cell. It's just like producing something. What kind of ethical dilemma that could arise from this?
I talked a little bit like like right now. I mean, human selling and buying of human organs is illegal, but is it illegal to buy and sell 3D printed organs or build or print your own organs in your own home, like build your own 3D print bioprinter, some things like that.
But I mean, you are not taking it from anybody else. You are
Right,
not.
yeah.
You are not taking
But
the line.
You still need like cells, like to start the process of printing a.
So,
organ.
is there any say or talk about having a shop that sells kidneys and
Right,
and
yeah.
any body parts, or it is I need a kidney, so they do it for me, particular, take my cells and do it? Is it for the patient himself or herself, or it's kind of it will be a market? You go and buy a heart, for example.
Right.
It will.
Depends on the situation. Like if I need some kidney or something, if they can take cells from my kidney and grow another kidney. If it's like some stranger gets a bioprinter and he starts printing all the organs, sells them, that's not ethical. So that's
Okay.
Because there's no regulation.
yeah.
Not yet. Okay. Other questions? Questions? Ready? I have another question. Now, these members, or these, what you call them, members, right? Or body parts.
Yeah.
These body parts have feelings. They feel pain.
Yeah, they do. And in fact, as Charles said, we can print the organs and we can test them like for new drugs, to develop new drugs, instead of using the mouse and all for the experiments. So that's another part in this.
Now, every member body part in us is alive because of the bloodstream, and it is tied to or connected to our bodies. So if you take a finger away from the body, it dies, right? So these members are just flying by themselves, or what? What brings them? What brings them life?
Yeah, part of it is actually that they it's the process and how they do it, not just the bioprint itself, but the types of cells that they're using, because they have to use stem cells with regenerative fat cells with some sort of a cell fabric to actually create the structure behind it. So they'll use kidney cells with the stem cells, with the fat regenerative cells to actually build that structure. And then they have to use, I think it's endothelial cells to produce their vascular network, the blood cells themselves. So, and some of that's produced separately, like I said, for the heart. They have to go through and make those blood vessels as a separate portion and then actually place those onto the heart. So it's, they say they were just barely touching on the edge of stuff like that because the human body's so complex.
Very good, very good. Now, yes. Question.
Yeah.
Can we hold this?
Yeah,
Would
you
you-
use your own stem cells actually from your bone marrow. Sorry.
Would you eat 3D printed food?
I don't know. I'd have to look at it first, maybe.
Would they eat it? Eat the 3D printed food?
It might
Yeah,
taste
no,
better.
no.
So you know.
I mean, I just feel like that's weird.
Another question?
I was just going to ask if they had it to where it was going to be regulated on who could buy the 3D printers, or is it going to just be whoever wants to? If you have enough money to buy a 3D printer, then you're able to do that. Did it talk about that at all?
Yeah, pretty much. The big thing is not the actual hardware itself. As he mentioned before, it's the software. So you could pretty much get a 3D printer from anywhere. Like, they do cost a tad bit much. Like, we have a 3D printer downstairs, but it's the actual software where you get into how does the cells react with this and actually printing cells. So, you know, just because you have a 3D printer, you can't really print the cells or organs. You actually have to have the software and, you you have to get samples from your own body and all that type of stuff. So it goes down to more than the hardware. It's more pieces to that. So does that answer your question?
Yes.
Thank you. Another question, please.
Is there concern that the expertise levels are going to run out? I think in your section, the availability of organs made by this process may be quite free, but are there going to be enough doctors to perform the surgeries? Is it going to be like a back alley kind of organ situation?
And that also goes back to Medicare and like the health system. I mean, it costs quite a bit for these type of transplants, and also to actually create. Was it like $800 to print just for the of the actual heart? Yeah. But to actually do the operation, and everything, cost-wise, is another issue.
Well, like with supply and demand, if there's a lot of demand and there's very little supply, then it's going to be something that only the wealthy can benefit from. And that was one of the ethical issues we all saw also. We don't know how far this is going, but that could be one of the ethical issues.
Can you tell please about how, if we change the liver from one person to another person, can it affect to other body, and how it is?
I mean, you guys can probably help me out here, but my understanding is you take your own cells from your own body to create the organ, which would allow for that compatibility to occur. I mean, do you have anything other?
Well, just from what I read, because there hasn't been a lot of actually clinical trials on this yet, the rejection rate will be minimized from current organ donors because of this, because it's using your own stem cells. So your cells will be compatible with your body, but there may be other things. Because you're using some gene therapy to actually reproduce these cells, there could be some rejection in that. So that was the only, like I said, there hasn't been really a whole lot on that yet, but they're thinking that it will be less rejection from organs that are 3D bioprinted.
I think we can stop at this point because this will open the door for many, many questions. And so would you please greet them for us for their effort? Very good. Open-minded and just absorb what they say and enjoy. Okay? Now, with this, I would start with the screen here, nothing on it for now, and TIYDS stands for? Very good. Let us look and the screen. Another hit, please. Hit another one. This is your day. Shine. One more. One. Very good. Would you clap your hands for the group who is going to start in a minute? So, please.
Good evening, everyone. I'm Darnell Henderson. This is Chuck, this is Scott, and this is Manny, and today we'll be talking about 3D bioprinting. So to start, I just want to let you know
Welcome to Global Technology, Tech 5173. This is a great day when students bring their labor during the semester, each group working on a topic of their own choosing, with a team of their own choosing. And they go and study to know everything about this thing. Of course, nobody can know everything about everything, but they will know at least better than us. Now, I want you to be
about how 3D printer works. All right, 3D printers work like inkjet printers. Pretty much, you design something on a computer or some type of software, get a model of whatever you want, then you send it to a 3D printer just like you would do when you're doing your weekly reports or you're writing research papers, and then the printer prints off what you want to print. All right, what we have here is just a brief description, kind of a graphical representation of how 3D printing actually works. The first part, you have the laser source. And, it sends a beam to kind of, form the material into what it's actually going to be. So it starts off as a kind of ink. White ball with the dropper with the red stuff in there is, it was the first lab-grown urinary bladder, and it was created in 1999. The second one, which is the top picture with the black background, is a kidney. That was created in 2002, and that kidney was able to filter blood and produce urine in an animal. The next one is a prosthetic leg, and the whole leg from the toes, the foot, the ankle, the knee, all of that was printed all from a 3D, and then it solidifies it. The next step is the elevator, and the elevator pretty much, like the name in itself explains it. What you have is different levels to what you're trying to print. So each time you want to print a level, the elevator goes up, and when it's finished, it goes up to the next level. The third is the vat, and that contains the actual like material. So it could be like mentioned later on, gold, silver, titanium, plastic, anything of that nature. Then yeah, that's pretty much how it works. All right, these are just a few things that I found as far as history. The first one, which is the